Evening, folks. Let's talk about audio. So this is a program I've got running. It's called Audacity, which you can get free online. It's a really good audio editor. Okay, I've made an audio recording in it. Here it is. This is an audio recording. And you can see that we are viewing it here as a waveform. Yeah, we can zoom in and out. We can view this audio in different ways. This file, this piece of information that we've recorded digitally. So let's look at it as a spectrogram. This is an audio recording. Okay, so this is a very useful and interesting way of analysing audio. So we've got kind of low frequencies across the bottom, going up and up and up. The higher the frequencies go, the higher you go up here, the higher the frequencies are. You can see it goes up to 20k. This is an audio. So I can select this bit and you can kind of hear this, that it's an S, it's S. It's very high frequencies. There's where it's most intense is around here at about 8k, 7 or 8k. Yeah, the bluer is less intense. Where there's no colour, as it were, there's nothing at all. Okay, so this bit down here, look, that's kind of a lower frequency. This, that the sort of TH of my voice is around 432, but there's quite a lot going on down here, quite low. This. Okay, so whatever this click is, which we'll talk about in a minute, you can see that it's occupying a lot of the frequency range. Yeah, so if I go into these spectrogram settings, well, it's already set from 20 Hz to 20 kHz. Cool. So that's already giving us, in some sense, kind of the human hearing range. Okay, so let's think about this. Let's view this audio in a third way. Kind of, if I highlight a bit here and go up to this spectrum plotter, this is giving us a frequency analysis. This is like a snapshot of that audio in any given moment. This is what we're more used to seeing. It looks like what an EQ reports back to us. Yeah, so that kind of click that I mentioned earlier here. So if we grab a bit more, replot, yeah, we can see, as you would expect, I hope, that it's giving us a lot of information up at the higher frequencies. There's quite a lot going on down here, like below 10 Hertz. Really interesting. Lower than we can hear. Most of it, though, is happening up here at kind of 8k and so on, which kind of correlates with here. Okay, so if I choose the S of my voice and replot that, again you can see that that's the kind of S. There's a sort of fundamental going on down here somewhere. Down here, down at 100 Hertz. What about kind of grabbing a bit over here? An audio. So that bit there, an audio. You can see that most of the intensity is down at a K, 2K. Okay, so I'd expect there to be lots of information happening down here. Down here. Yep, we can see information happening around 100 Hertz up to a K. An audio. Yeah, so we're viewing this audio in different ways. The waveform, a spectrogram, is an audio recording. And then, in a sense, what we're used to seeing, something more like what an EQ gives us. Just the frequencies across the bottom here and the intensities up here on this scale. The loudest point of this snapshot is way up here at minus 38 dB. That scale of loudness we will explore in a lot more detail another time. Okay, so you can see this click here. I deliberately tapped a pen, a biro, on the laptop as I made the recording. All right, so we're going to zoom in and just check out what we see as we zoom further and further in. Okay, so this is the great thing about this app, is that as you zoom in and in, you get to the point roughly at this crazy scale where you actually now see every individual sample. check it out. So if I just highlight so much and zoom back out again, you can see we're actually kind of grabbing the tiniest bit. You can really get a good sense of how much we are zooming in by. So Audacity allows us to zoom in as far as you can go. It allows us to get right down to the resolution of the sample itself, each individual sample. And 44,100 samples are taken every second, which we will say much more about another time. So why do we care? Because at this resolution I can grab my pencil tool and kind of get rid of that click. I can make an edit and just smooth out that click. See that? So if I zoom back out, what effect has that had on the audio overall? Here we go. This is an audio recording. Yeah, so you can see that it's reduced the click a bit. This is an audio. Okay, but not enough. So let's go back in. Okay, and that's an interesting pop-up screen. What does it tell us? To use Draw, you've got to zoom in further until you can see the individual samples. Okay, my bad. Let's do that. So there you go. So now I can make this fine edit of that click. Obviously I could just delete that at a much higher scale, kind of out here as it were. But it's just interesting to think about. This is an audio recording. It's interesting to think about the very idea of individual samples. Okay, so of course what I could do is highlight that and delete it. So now we've got, this is an audio recording. Excellent. Okay, great. So I recorded my voice into Audacity. Okay, I'm going to export this as an audio file now. Let's do that. You probably heard my phone just go off in my pocket. Slightly annoying. So export audio. What options do we have? Well, we've got WAV, we've got AIF, audio interchangeable file format. Very crudely speaking, we can think of WAVs as PC format audio files and AIFs as Apple Mac audio files. That's, you know, horribly simplified, dare I say, but for now I'm going to choose AIF. Okay, I'm going to stick it on my desktop and call it audio recording. Alright, and then let's save that. And I'm not really interested in any of this stuff. Okay, and now let's take that audio file into Logic and think about it further in there. Okay, see you in a minute.